Okay, I was requested to do triple integrals, so today we're going to do triple spherical integrals. So we need to solve this by translating this into spherical coordinates. So first off, let's imagine this shape. So we know z is between the square root of x squared plus y squared. That's what z is between. It's between that and the square root of 2 minus x squared minus y squared. So if we just look at this, we know that this is a sphere, because we have, or no, it isn't a sphere. It's less than z squared. So a, okay, I don't really know what this means. This means that a circle, a circle on the xy plane is less than, I don't know. Let's look at this one. This one makes more sense to me. This one is z squared is less than 2 minus x squared minus y squared. So this gives us x squared plus y squared plus z squared is less than or equal to 2. So this is saying, since this is a sphere, it's less, z is below that sphere, and then we also know that it's the upper half of the sphere, because if it would be, that would be the bottom half. So if we have xyz plane, we have a sphere on the upper, and then whatever the bottom is, I don't know what the bottom is. Um, Well, let's come back to that later. X is between 0, oh, and then this is at, wait, what am I doing? X is between, or Z is between this. This isn't that. It'd be like that. It'd be below that sphere. So it'd be below that sphere where this is 0, 0, root 2. Because then, yeah. Okay, so that works. But we don't know what the bottom is yet, I guess. Is this right? Sorry guys, let me continue. So, we know that 0 is less than or equal to y, which is less than or equal to square root of 1 minus x squared. So we know if we look at this, y squared is less than x squared plus y squared is less than 1. So, oh, I'm slow. This is, this here means that it's the sphere, this includes the entire sphere. Why was I thinking that way? And then this says that it's only, this is the input space for x and y. So, I don't know how this is gonna work, because we have this sphere, but then we have this input space of, it's a smaller circle. So it's gonna look something like small circle, and then it goes up, and then it goes like that. Like that. and then it's a circle like that. It would be, but it's only that part, and then it goes below. Okay, then we know that y is less than, or x is less than, is from 1 to 0. So x is on this, so it's only this part that counts. So we have to disregard, if this is the y-axis, there's only this half. So we know 0 is less than x is less than 1. We know that 0 is less than rho I don't want to do the entire row thing here, because I think this, we already know x and y are like this, so we could just know visually theta. It's only in this quadrant, theta, so theta is from pi over 2 to negative pi over 2. The theta, which is less than or equal to pi over 2. So just setting up this triple integral, we have negative pi over 2 is less than theta is less than or equal to pi over 2. Then we have something is less than or equal to something, which is less than or equal to something, less than or equal to. Here we have rho, and here we have phi. So, now let's figure out what this is. I delayed figuring out this is. Z is less than x squared plus y squared. And we know that x squared and y squared is less than or equal to 1. Okay, we know x squared and y squared is less than or equal to 1. So at most, it's at 1, but then it also goes all the way down to 0. So if z, is greater than or equal to, z must be always, z must be greater than or equal to, oh, that's z squared. Z squared. We take the square root of both sides. We know x squared. We know the square root of that is less than or equal to 1 again. So does that mean that this is less than or equal to 1? Or greater than or equal to, z is greater than or equal to 1? Okay, I think this is time to change it into rho and theta. So we know x squared plus y squared, that they're both rho squared. Rho squared, what is it? Is it cosine phi, sine phi? If, why do I have to do this again? If this is phi, then we're trying to find what r would be given rho. So if rho is like this, and then we're trying to find that, this is, this would be equal to this. So it'd be rho times opposite over adjacent, so sine of phi. So they're both, x is rho squared sine squared phi cosine theta, cosine squared theta. Y is the same thing. So it's just sine squared theta. So that means that these cancel out to 1 because it's cosine squared plus sine squared. So it's just rho squared sine squared theta, phi, sorry, is less than or equal to, it would be rho squared cosine squared phi. Crossing out these phi's, we have the rho squares. We have sine squared phi is less than or equal to cosine squared phi. So we just have sine squared minus cosine squared, which, okay, sine squared phi minus cosine squared phi is less than or equal to 0. But we know what sine squared phi minus cosine phi is. I believe that is cosine of 2 theta. I should figure this out. We know that cosine of 2 theta is equal to cosine squared minus sine squared. So we say that we just flip it, cosine squared phi minus sine squared. We have to change the greater than, we have to change the inequality. So that means that this is equal to cosine of 2 phi is equal to this. So this is just equal to cosine of 2 phi is greater than or equal to 0. When is cosine greater than or equal to 0? When phi is like, wait, cosine is like that. So it intersects at pi over 2. So phi ranges from 0 to pi over 2. But, so 2 phi is 0 is less than or equal to pi over 2. So that means that 0 is less than or equal to phi, which is less than or equal to pi over 4. So really, phi can only go to, like, here. So that gives us like an ice cream cone shape. So what we're given is like this, but x has to be positive, so we cut out that part. Okay, so phi is between 0 and pi over 4, and rho is between, well, we know rho up here is pi over 2, or sorry, root 2, and then it will always be root 2, because where it intersects, it's still root 2. So it's between 0 and square root pi plus square root 2. Okay, that's all just for finding the bounds. Now let's actually solve it. Oh, we should also find this. This is rho, it'd be rho squared cosine, oh my gosh. Oh my gosh. Let me make a new one. Continuing on, we have our bounds are from 0 to root 2, or wait, let me, before fully writing the integral, let me just write the bounds. 0 to root 2 rho to root 2. I'll just say 0 to root 2. And then we have negative pi over 2 to pi over 2. And 0 to pi over 4. And then our integral, before putting the bounds in, because I don't know what the correct, or what the best order would be. So x would be rho cosine, no, rho sine phi cosine theta times rho cosine, no, rho sine phi cosine, oh my gosh, sine theta. Oh, since all these are separate and they don't include each other, we don't have to do it together. And then we need the Jacobian rho squared sine phi d rho d theta d phi. So rho theta phi. So rho goes from 0 to root 2. Theta goes from pi over negative pi over 2 to pi over 2. And phi goes from 0 to pi over 4. Okay, first the rho. Combining all these, we have from 0 to root 2, rho to the 4, d rho, oops, d rho, which then gives us 1 over 5, rho to the 5 from root 2 to 0. So this gives us well, I guess 4 root 2, because it'd be, you get rid of the square tool, yeah, 4 root 2 over 5. Okay, now time for sine, or for time for theta. So it's the integral from negative pi over 2 to pi over 2 of, let's see, cosine theta times sine theta. That's it. Cosine theta sine theta d theta. How do we integrate this again? We would need to do... no, that can't be it. Is it just u sub? That sounds too easy. That sounds too easy. Well, let's do u sub. My teacher always tells me to do a quicker version of u sub, but I can't. It just doesn't compute to me as well. So, we know u equals sine theta, I guess. And then du equals cosine theta d theta. So then, and then u of pi over 2 equals 0, and u of negative pi over 2 is equal to, oh no, not 0. That's equal to, sine of pi over 2 is equal to 1, negative 1. So we have the integral from negative 1 to 1 of u du. Right, yep, which is equal to 1/2 u squared from 1 to negative 1, which is equal to 1/2 times 1 squared minus 1/2 times 1 squared times negative 1 squared, which is 1, which is equal to 0. This seems wrong. What did I do wrong? I mean, it's xy, so I don't think I did anything wrong. U is equal to, yeah. So 1/2 times 1 squared is 1, minus 1/2 negative 1 squared, which is 1. So it's equal to 0. So that would mean since it's multiplied, the entire integral is equal to 0. That cannot be true. That cannot be true. That cannot be true. I think that's true. I'll check, but I believe that's right. that the entire integral goes to 0. Yeah, it's not true. What did I do wrong? 0 to root. Oh, oh my gosh, I see what I did wrong. In the actual integral, in the beginning integral, y goes from 0 to whatever, square root of something. So y is always positive, so it's really only in the first quadrant, so it's not this. I'll just update this, because I didn't see the answer, I just saw the way they did it. So this is 0. So that further going down, this is 0, which then means this is 0, u of 0, 0, which means from 0 to 1, which means that this is from 0 to 1, which means that this is 0, which means that we get 1/2. Oh my gosh. One half. And now we get the phi integral. So now we're left with the integral from 0 to pi over 4 of sine phi sine phi cubed, right? Yeah, sine cubed phi, sorry. Sine cubed phi d phi. Okay, we have to use an identity here. We know that sine... Oh, can we just use... Oh, we get to use an easy identity. We don't have to use double angle, I think. Right? Yeah. So we're just left with 1 minus cosine squared phi times sine phi d phi. So set u is equal to sine phi, or u is equal to cosine phi. Du is equal to negative sine d phi. So we get 1 minus u squared, which is negative version d phi, from du from the integral from u of pi over 4, which is root 2 over 2, and u of 1, 0, which is 1. So then, well, it should be negative, but then we can negate it by flipping the signs, flipping the bounds of the integral. That gives us u minus u cubed over 3 from 1 to root 2 over 2. So that gives us 1 minus 1/3 minus root 2 over 2 minus root 2 over 2 cubed over 3, which is 1 minus 1/3 minus root 2 over 2, plus 1 over 6 root 2. And then this, I'm going to change this to 1 over root 2. So this gives us 2 over 3. No, I'm not going to change it to that. And then multiplying this by root 2, we get 12 over root 2, or root 2 over 12. Okay, so So this is equal to 2/3 minus, so this would be minus 6 root 2 over 12 plus root 2 over 12. So this is equal to 2/3 minus 5 root 2 over 12, which is equal to 8 over 8 minus 5 root 2 over 12. Then we need to multiply this by what we already have. So we have the row part, which is 4 root 2 over 5 times 1/2 times 8 minus 5 root 2 over 12. Okay, so first off, this goes to 2 and this cancels out. So then we have 2/5 times 8 minus 5 root 2 over 12. This cancels out again where this goes to 6. So over 30, and then we get, this is 2 root 2. So then 30, then multiplying all the root 2's, we get 8 root 2 minus 10 over 30, which is equal to 4 root 2 minus 5 over 15. Okay, let's check. Wow, I got that right. Wow, I'm very surprised. Normally, you'd never get this right, or I would never get this right, because it's such a long arithmetic process. But I made only one mistake, and I got it right. Thank you guys for watching. I'll see you guys tomorrow, and goodbye.